What problem does the OpenWorker repository solve?
OpenWorker addresses the need for an AI assistant that doesn't just chat but actually completes tasks. It runs locally on your machine, giving you full control over your data and the models you use. The app handles things like document creation, Slack replies with data, and calendar updates, all while keeping your information private.
How is the repository structured?
The codebase is organized into several key directories. The coworker/directory contains the Python backend, including the agent engine, connectors, and memory management. The surfaces/GUI/folder holds the React-based desktop application with a Tori shell. There's also a SDT/directory for speech-to-text functionality in Rust, and packaging/ for build scripts and installers.
Can you explain the main components and how they interact?
Sure, the core of the system is the turn engine in coworker/engine.py, which manages the agent loop. It coordinates with the provider client for model interactions and the tool registry to access available tools. Connectors in coworker/connectors/ handle specific integrations like Slack or GitHub. The permission engine ensures user approval before any sensitive actions are taken.
What's a particularly interesting technical detail from this repo?
One standout feature is the permission handling system. The permission engine ensures all risky actions, like sending messages or running shell commands, require user approval. The approver function is injected to handle these permissions, and the system distinguishes between different types of approvals, such as one-time or always allow for specific tools.
Another technical detail worth highlighting.
The use of the Model Context Protocol, MCP, is fascinating. It allows for seamless integration with various tools and services. The MCP client in coworker/MCP/ facilitates communication with external systems, and the tool registry manages all available tools, ensuring compatibility with different connectors and providers.
Can you walk through a specific file or function in detail?
Let's look at coworker/engine.py and the turn engine class. This class is the heart of the agent loop. It initializes with a provider client, tool registry, and permission engine. The max iterations parameter prevents infinite loops, and the approver function handles user permissions. The permission request class encapsulates the details needed for each approval request, including the tool name, arguments, and metadata.
What about the cloud.py file in the coworker/directory?
The cloud.py file manages interactions with the OpenWorker cloud service. It handles sign-in processes using Auth0's authorization code with PKCE flow. This ensures secure authentication without storing sensitive information on the server. The file also manages OAuth for connectors, allowing users to set up integrations with services like Slack or Google with minimal manual input.
Are there any limitations or caveats to be aware of?
Yes, the system is in beta, so some features may have rough edges. The Windows version isn't yet code-signed, which might trigger smart screen warnings. Additionally, while the app is local first, the cloud component is necessary for certain OAuth flows, which means some data does travel to the cloud for authentication purposes.
How does the app handle automations and recurring tasks?
OpenWorker supports automations through the coworker/automation/directory. The scheduler.py file manages recurring tasks, and store.py keeps track of automation states. These automations can run on a schedule, producing deliverables like morning briefs or weekly reports, and they log all actions within the app for review.
What about the use of different AI models?
The app is designed to be model agnostic. Users can bring their own API keys for providers like OpenAI, Anthropic, or Google Gemini. It even supports open-weight models via Llama. The providers/directory in coworker/ contains the necessary code to interface with various models, ensuring flexibility and avoiding vendor lock-in.
How does the app ensure privacy and security?
Privacy is a core focus. All processing happens locally on the user's machine, and sensitive data like model keys and connector tokens are stored in the app's local secret store. The only cloud interaction is a small service for OAuth handshakes, which users can opt out of by using manual credentials instead of the managed connectors.
What's the process for contributing to the project?
Contributions are welcome through GitHub issues or pull requests. The project is actively developed, and contributions should align with the internal roadmap. When submitting a PR, including screenshots of the issue and its fix is encouraged to help maintainers understand the problem and the solution.
Can you explain the role of the SDT/directory?
The SDT/directory contains a Rust-based speech-to-text sidecar. This component allows for voice input within the OpenWorker app, enhancing accessibility. It runs separately from the main Python processes, ensuring that voice recognition doesn't interfere with the performance of the agent loop or other tasks.
What are the testing strategies in place for the project?
The project includes a comprehensive testing suite. Backend tests are run with PyTest, while the GUI has unit tests and end-to-end tests managed through NPM. The test/directory contains the backend test suite, and surfaces/GUI/ has tests for the frontend. This ensures that both the Python backend and React frontend are thoroughly validated.
Who should actually care about this repository?
Anyone looking for a powerful, privacy-focused AI assistant that integrates deeply with their existing tools and workflows should care about this repository.